I think electron clouds is a really important topic for this course because everyone kind of learned chemistry, has a basic understanding of electrons in an atom. And this kind of goes back to the Bohr model, where you have a nucleus in the center, and then you just have one ring with an electron going around it. And that's the classical image of an atom. And so to get a better understanding of more complex topics in the course, like Lewis structures, covalent bonds, you need to have a good grasp on electron clouds.
I think I'm with you in the sense that if there are things associated with electron clouds that if you can begin to accept that electrons exist in places other than definite orbits, that it will help your understanding of some of those concepts. For instance, so you mentioned electron clouds, and electron clouds are a step beyond the Bohr model. But I want to go back to the Bohr model for just a second. So with the Bohr model, there's a nucleus that is positively charged, and there is some definite orbit which has an electron in it. And that electron is negatively charged, and it's attracted to the positively charged nucleus. And because it's moving around, I always think of it as, in the Bohr model at least, of some sort of like centripetal force. And so it's got an attraction pulling it into the nucleus, but it also has a force allowing it to go away from the nucleus, and that keeps it in that definite orbit. That's what the Bohr model is. But there's going to come a time when we don't just worry about single atoms, we worry about molecules and how they're held together. And so we're going to do some things, and maybe this is where this video comes into play, with Lewis structures, trying to understand what the shape of molecules are and how they're held together by covalent bonds. And covalent bonds are a sharing of electrons. And that sharing of electrons helps to hold two atoms together. But if I still have a Bohr model concept in my head, it is really hard to figure out how electrons can be shared to hold two atoms together. So I'm going to draw a couple Bohr models. In fact, so there's one atom, but I'm going to draw two other ones down here. So here's a Bohr atom with its electron. Here's a Bohr atom or Bohr in the nucleus. Here's the atom. Here's the electron around the outside with an electron in it. Now, if I'm still thinking of a Bohr model with electrons traveling in a definite orbit, it's really hard for me to figure out, I think, that when this electron gets around to this side of the atom, how is that electron over there shared by this atom over here? It seems pretty, about as let's put it this way. If people share things with me that way, I feel pretty unloved. Right? Yeah, we can share it, but I'm going to keep it over here on the other side of it, right? And so if you're in a Bohr model with electrons orbiting in definite orbits, it's really hard to come up with a concept of shared electrons in a covalent bond. If, however, though, we move beyond that to saying, hey, here's the nucleus of one atom, and these electrons are in some sort of electron cloud out there, and I'm going to stick it here for now. And here's another atom with its electron. I'm going to put that one there for right now. And those electrons are not in a definite path orbiting the nucleus, but they spend their time, most of their time in this region. And in fact, in this case, they spend most of their time in here. Now, if I've got 2 electrons in here and they spend most of their time in between, that sounds like real sharing, right? And so it's possible to imagine that these 2 electrons are attracted to this positive nucleus. These 2 electrons are attracted to this positive nucleus. And so that begins to help to hold this molecule together. Whereas over here, while these electrons are on opposite sides, that's going to be forcing the atoms apart. And so in order to begin to have a deeper understanding of how sharing of electrons can hold atoms together in molecules, it's really helpful if you can begin to internalize some level of comfort with electron cloud density and electrons having some probability of being in these orbitals, but definitely better to move beyond some idea of circulating orbits. And so that's why electron clouds are useful, because if you get to sharing of electrons, then we can get to covalent bonds holding molecules together, and eventually we're going to get to Lewis structures, and even beyond that, molecular shape. And molecular shape and the electrons will get to chemical properties. Oh, I spelled properties wrong.
Could you move the paper a little down? Yep.
Sure. Yep. Chemical properties and reactivity. So if we get to sharing of electrons, we can get to covalent bonds, which can get us to the structure of molecules, which can get us to molecular shape. Chemical properties and reactivity stem from that. And that's where the useful part of chemistry is, once you can get compounds that will do things that you want them to do. And that's where we're headed.